Okay, so the last thing I want to talk about is misleading graphs. And your book talks a little bit about this, but not as much as I think that they should. It's such a really important topic, and it's something that we see often is we do see a ton of graphs that are misleading. Um, and you may not even notice it. So there's a ton of them on the news and newspapers, on websites, and it's really important to be able to pick these out. So one thing if you look in your text, at the end of a lot of chapters, they have a uses and abuses section. So I do encourage you to read that in your text. It's at the end of chapter 2, and you can go into Blackboard for the exact page number and things. But it does have abuses of statistics. So it is easy to create graphs that are misleading and really unethical. So I want you to watch these 4 videos. They're all very short, just a couple minutes each, so they're not long videos, and I just kind of go through things to watch for when you're looking at graphs or when you're reading articles about things that could be misleading. So there's a couple main things I want to talk about, and I'm going to use some of the examples down here to help me. But again, these will go into a little bit more information, and I really want you to watch them so you can be more aware of what to expect and to what to look for. So the first most common way that we can mislead the audience is by not starting a vertical axis at 0, particularly when publishing bar graphs. Now, on a case-by-case basis, it may be possible to not start a vertical axis at 0 if you have some sort of line graph. It just depends on the data. As long as the data is still nicely proportioned, it may be possible. But for any sort of bar graph, histogram, Pareto chart, it doesn't matter. You have to start that vertical axis at 0. Because if you don't, it distorts the size of the bars. So I'm going to look at these 2 examples with you right now. So 37, 38, these are just from the end of your text. So here I'm looking at sales for a company. And let me see if I can zoom in a little bit. And I have the 3rd quarter, the 2nd, the 1st, and the 4th. So they have the quarters rearranged here. So we're kind of using a Pareto chart in this case. If I'm being honest, first of all, I probably wouldn't do that. I think it's a little confusing to have 2nd, 3rd, 1st, and 4th out of order. So I would not recommend rearranging things that have natural ranking. If you have something that does not have natural ranking, maybe like movie genres or something like that, then it's totally fine to use a Pareto chart. But where this has natural ranking, I would really not rearrange like this. I think it's confusing to have it go out of order from time. So that's one issue that I find to be problematic in this particular case. The other issue is that we're using a bar graph that is not starting at 0, it's starting at 80. So let's look at what's happening here. So this height, I'm going to just estimate here. Looks like it may be at, let's say, 125. It's a little bit above 120. This bar, if I kind of go over here, it looks like it's around 105. This bar, sorry guys, this bar here looks like maybe it's at 101 or something like that. And then this bar here, again, just kind of scrolling over, it looks like maybe it's at like 97. So we're looking at different heights, and these are sales in thousands of dollars. So these numbers are actually not that far apart, but it looks very dramatic. So for instance, look at the heights here. So if I look at this 101, and I kind of bring it over here and kind of just copy it over, it looks like I could fit 2 of those within this first bar. So if I could fit 2 of something, this should be twice as much. But it's not. It's only 25 units more. It's only 1/4 as much, actually, or 1/4 more, not double. So when you don't start at 0, you distort the bar heights, and it makes it look like the 3rd quarter was so much better than the 1st quarter that it was double as good, but it really wasn't. So not having that 0 there distorts how good something really is, or the amount that you have. And what we should do instead is we should start that at 0. So I'm going to just count by 50s to make it easy. So 50, 100, 150, so on. So that first height should be something like this. That second height, that 105, is like something like this. The 101 is going to be right there with it. And then the 97 is again right there. So those heights are really quite similar if we were to start at a zero axis like we should. And that's the problem. So if someone is reading quickly, and this happens all the time, sorry, I want to shut that off. If someone is reading a graph quickly, and this happens all the time, you're looking through a magazine, you're watching the news, you're not paying attention to the axes. You may not even have time. I notice when I watch the news, they put things up for so fast that I don't even have time to look at all the details. And it's making it look like the third quarter was substantially better than the first when it really wasn't that big of a jump. And it's the same issue here. So here you have middle school, high school, and college. Again, let's look at the heights. So this one looks like it's about 70, if I kind of move this across. This one is clearly 60, and this one looks like it's also 60. But notice that you're not starting really at zero, or it's not consistent, right? If you're going from zero, it's 0 to 56, and then you're going by units of 4. So that's not a consistent scaling. If I were to redo this, so let's see, I have 10, 20, 30, 40, 50, 60, 70. What's going to happen is your middle school graph is going to be about here, and then your two other graphs are like right here. You're going to see that there's not that much of a difference. But because we're not using a consistent scale and starting at 0, we're distorting the graph. This one here, it looks like, right, that 60, looks like I could fit 2 of those 60s in the 70 bar. So this should be twice as many. This should be 120, right? But it's not. So this is an extremely easy and common way that graphs are misleading, is when someone uses a bar graph, but doesn't start at 0. So watch out for these. They occur all the time. Really, it's kind of sad how much they occur. So watch out for them. Because they distort the viewer into believing that, someone in middle school, the percent that responded yes is substantially different than someone in high school or college, but it's actually not. It's very little, right? 10 people, not double or half or something like that. Another issue would be 3D effects or tilted images. So anything that's 3D or tilted can distort. And you'll see that here. So if you look at your percentages, you have 38% here, 38% here, 20%, and then you have 4%. Because it's tilted, it's really difficult to see the sizes of the proportions for those segments. And it looks like the yellow segment to me is bigger than the blue segment, right? This looks like it's more than the blue, but they're actually the same number. So because it's tilted, and that 3D effect as well is distorting the sizes. So our graphs should be clean, organized, easy to read, neat. And here's another example. So this is a pictograph. So again, 3D, no 3D graphs. Pictographs in general, some of them on rare occasion are done well, but overall, no. So a pictograph is when you use a picture to display your data. And they do this a lot in elementary school. But they also do it just to make things fun, right? Oh, it's more interesting. We're going to use pictures. This is great. So here we're talking about oil imports. So they're using a barrel of oil to represent the height. Now, this one does start at 0, so it's doing good, right? Because you have 500 as you're scaling in each case. So this height looks like it's about 750. And I'm going to estimate this height is about like 1250 or something like that. So the heights look good, right? The heights seem to be balanced. But what happens when you blow up a picture to be the right height is that it gets wider as well. And that's the problem, is that you're changing the area. So the area is not consistent anymore. Right? If you wanted to use the height, you could do that, but it should be the same like width, right? So like your barrel should look like that to make it be accurate. But when we blow up a picture, we can't just blow up the height because the picture gets distorted, it gets weird looking. So we blow up the width as well. But what happens now is the areas are not consistent. So this picture here, it looks like I could fit like 3 or at least 2, if not 3 different barrels in this barrel, but this is not double, right? So the areas get distorted, which again cause the viewer or the reader to think that there's a bigger change that there really is. This looks like so much more to me than this one, but it's not. It's only about, what, 500 units, 500 barrels in millions. Now, I know that's still a lot, but I mean, this looks like it should be double what this is, or even triple because of that widening. So we don't like pictographs, particularly when they use as bars. We don't like 3D images. We need to start at 0 on that vertical scale, always for bar graphs. And again, most of the time for other graphs too, although there are a couple exceptions here or there, but these are some ways that we can distort data. Other things that you can see as well is that if the data, if the graph is too congested. So sometimes there's so much going on, you can't even figure it out. So that's a bad graph. If you don't have labels, right? A lot of graphs are missing labels on their axes. They're missing even the tick marks, where like some of them don't even have numbers. They just have pictures. So if you don't have the labels, the title of the graph, the units, if it's confusing in any way, it's probably a bad graph. And there's also better graphs out there too. So for instance, pie charts and circle graphs, people tend to love. A lot of mathematicians don't like them because visually it's kind of hard to figure out those segments, right? If I have 30% and 35%, visually I may have a very difficult time distinguishing between those two. But if I use a bar graph, then I can actually see that there's a change in heights, right? So pie charts themselves are not bad. They are when they're done like this because it's tilted in 3D. We don't like that. Pie charts in general are not bad, but there's a lot of times a better graph out there. So a bar graph is usually much easier to read, to see those heights, than a pie chart is. So you always want to think about when you're graphing, what's the best graph that I can use to show my data? When you display data, it should be clean, neat, easy to follow. You should not be misleading anybody or trying to make the data look different to support your theory or support your political agenda or your personal beliefs. And there's a lot of that out there. So you want to be careful as you go through and start looking at these graphs in the real world. So check out these other videos, which just kind of very quickly talk about different types of misleading graphs, and just in general, what information you should watch out for and things you should ask when you're seeing things on the news, in papers, in magazines, on Facebook, on Instagram. So those things in particular, you need to watch your sources there when you're reading things.